All right, last chapter, pretty much. Okay. Wow. Okay, we've got one section in chapter 9 to do, but that's going to be really easy, and honestly, it's kind of fun. So chapter 8 is about using integrals to calculate useful things. So it's all about applications. And it gives us a set of general directions on how to use integrals to model problems and to solve problems with them. And then it gives us various situations. So we're going to do some really cool stuff as we go through this chapter. But the first thing that we want to talk about is to go through once again the strategy for modeling with integrals. So as we've gone through, we came across this in chapter 5, where they gave us max-min problem-solving strategies. And I have told you many times that there's no way that I can teach you how to solve every problem that there is to solve. But what I can do is give you a list of steps to go through, things to check out, things to consider, so that hopefully it will help you organize your thoughts, and by the time you get to the end of that checklist, you'll be like, oh yeah, I know how to do that. Okay? Because remember, in all of these situations, the goal is to take what is unfamiliar and what looks intimidating and turn it into something where you can say, oh yeah, I can do that. Okay? And so that's again what we're looking at here. So the first step in this whole process is really trying to find our function. Which is sometimes easy and sometimes hard. I think this step is really about trying to make sure that you know what you're calculating and what you are modeling. That you know what your integral needs to produce, instead of just saying, oh look, there's an equation, I'm going to integrate it. Okay, without really thinking about what that means. So an example that we might come across with something like this is maybe you've got the edge of a container. So if we let this be our x-axis, maybe from here to here, this is the cross-section of some kind of container, and you want to find the volume. And f of x models whatever that cross-section is. And then if we were going to try to find the volume, well, I'm going to look at some value at some random x value. I'm going to surround it with some chunk that has a distance or a width delta x. And then if I'm trying to find the volume, it's going to be the height times the width. Okay? In some way, shape, or form. Or maybe that's going to be the area or whatever it's going to be. Okay? And so step 1 is really figuring out and thinking, and it's all those steps where you make sure you understand the problem. It's the step where you write down your knowns. It's the step where you make your find statement. It's the step when you look in your toolbox and you see what kind of tools that you have and find the function. Step 2 is to write the definite integral. So we're going to take this and turn it into some kind of integral from a to b of f of x dx. And then step 3 is just evaluating that integral. Using all of the techniques that we have. good? In some ways, I think these instructions are too general because they want them to apply to every possible situation. And I think we'll find that we'll have kind of subsets of instructions depending on what it is that we're looking at. Maddie. Okay. All right, so we good? So we're just going to do some problems. We'll see how many problems we get to. And we'll go from there. Okay. Right, we ready? We good? Okay, so let's start with, what is it, page 390, number 22. If somebody would read it for us, please. Okay, so let's talk about a couple things here before we actually jump into this. So let's start by, we're going to back up and do a little physics, because as we've said before, calculus was really invented so we could do physics. Studying calculus by itself is a little weird. So let's start with talking about what this kilowatt means. Okay, what does this prefix kilo mean? 1,000. So this is really going to be 1,000 watts for starters. So AP Physics people, keep your mouth shut for a minute. Does anybody else remember from freshman physics or any other physics class you might have taken what a watt is? Are you an AP Physics student, Priya? I told you, I said keep your mouth shut. It's true it's a unit of power, but what is it? What is it? Anybody remember? Anybody else remember? Okay. It is related to joules. How is it related to joules? AP Physics people, you can open your mouth now. It's 1 joule per second. Okay. So as Priya said, it is the unit of power. And power is how much energy is used or given off every second. So where do you come across watts in your life? Electricity, but there should be a specific place where you probably come across watts. Light bulbs, okay? So what kind of light bulbs do you have in your house? If you have LED, that gets much more complicated. Okay, I was really going to go for what wattage light bulbs do you have in your house? Okay, so you might have a 40 watt light bulb. And if they're the new kind, then it's like a weird wattage because they're more efficient than they used to be. Okay, but a 40 watt light bulb means that the light bulb gives off 40 joules of energy every second. So this problem talks about kilowatt hours, which I think are the stupidest unit I've ever heard of in my entire life. And I always have to think about it. Okay, so that's even worse. Kilowatt hours at least is metric. Okay, so We know that a kilowatt is a joule per second, and an hour is some kind of unit of time. So if we did some converting here, we could somehow, and that's why I'm going to make this a dashed line, we could somehow get rid of the hours and the seconds. Okay, we'd have to do a little math here. I'm not going to do the math because I don't really care. I think when you all grow up and become engineers, you'll find that they still use stupid units. It is. But anyway, what my goal really here is to show you is that a kilowatt hour is a unit of energy. So even though it has that time in there, a kilowatt hour is energy. So when you're supposed to find the number of kilowatt hours, you're looking for the amount of energy that was consumed by that house. Okay? I feel, and if you're in AP Physics, you know this, that units are a good way to check things. If the units work out, then you probably did the problem right. To a factor of a half that's floating around somewhere that you can't really figure out. But you will have squared the right things, you would have divided by the right things if you get units that make sense. Okay? And that is a flaw of your calculus book, is they use bizarre units. Okay? So everybody, so just wanted you to get an idea. Okay, real world, we're talking applications. So now let's talk about that formula that they gave us. So they said that C of t was equal to 3.9 minus 2.4 sine pi t over 2, where t is measured in hours after midnight. And this equation is the rate of consumption. Oh, I'm sorry. It is. Thanks, Sarah. So let's do a little more physics before we get into this. What is a rate? What do all rates have in common? It can be it's the derivative of something with respect to what though? Because that's the key to a rate, time. Okay, so a rate is always something per time. So in this case, this rate of consumption is going to be the amount of energy consumed per time. Probably hour, because t is measured in hours. Okay, so now let's just file that away for a minute. Okay, so you've got that equation. Think about your life, think about your house. If you're living in the residence houses, think about your house at home, your family and what they do. When do you think you as a family consume the least amount of electricity or the least amount of energy? Probably at night. Okay, hang on. Okay, so at night. So what time is the middle of the night? 0, right? And that would be midnight. So if we look at this equation and we take t equals 0, which means we take c of 0, that gives us 3.9 minus 2.4 times the sine of 0. And we're going to do this again. What's the sine of 0? 0. Okay, so that whole term's going to go away. It only makes me cringe more when I ask that question and no one answers. It'll be a big fat pop quiz on trig functions coming your way if you don't shape up. Okay? So that's a pretty small amount of energy being consumed. But we don't really have anything to compare it to. So what time do people start getting up in your house, Zoe? 7? Well, not 8, because 8 you have to be here. Okay, see what time do people start getting up in your house? 6. Okay, so 6, 7 o'clock. All right, I'm up at 5, but that's a different story. Okay, so let's take 6 just because that's what I've done with my notes and because it is easily, it's a multiple of 12, or part of 12 rather. So if I take C of 6 hours when people are getting up and running the shower and running the hairdryer and you've turned the television on and you're making toast for breakfast and all those things. So now I've got 3.9 minus 2.4 times the sine of pi times 6 over 12. Although this doesn't make any sense. It's not quite right. I don't know when these people wake up. But what do we get? Because I guess these are lazy people. And they don't get up at 6. You do not need a calculator. What is this? Pi over 2. Sari, what's the sine of pi over 2? Is 1. So this is going to be 3.9 minus 2.4, which you can do in your head, and is going to be 1.5. Okay, so these people must get up late. You don't really get that. But how about 6 o'clock at night? What's T going to be equal to at 6 o'clock at night? 18. So let's take C of 18. So that's going to give me 3.9 minus 2.4 times the sine of 18 pi over 12. What's 18 pi over 12? 3 pi over 2. Maggie, what's the sine of 3 pi over 2? Negative 1. So that's going to cancel with my negative sign out here. And what's 3.9 plus 2.4? Okay. I don't know, maybe, I don't know why. I don't understand it either. And let's try noon, because that was Zoe's comment before, that everybody's at school or work and nobody's home, except your dog, who may be watching television, maybe not. My dog used to listen to the radio. So that would be 3.9 minus 2.4 times the sine of 12 pi over 12. Well, so it's this 12 pi over 12 is pi, and the sine of pi, Rebecca, is 0. So this is just going to be 3.9. Okay. It's your book, and your book is stupid. Could be a weekend. Maybe. The whole thing is, it's your book. Okay. So I just wanted you to get an idea of how this kind of works. Okay, where this might come from, why there's kind of that sine function in there, because it's a cyclical thing throughout the day. Okay, so now we can actually solve the problem, now that we've got some background. You don't have to do this every time, but I think it's important. Sorry, you're unhappy. What's going on? Okay, I'm good with that too. All right, so remember, what's this equation measuring? Well, no. No. Yeah, no. No. Okay. So this is a rate. It's the rate of consumption. And actually, what are the units going to be for the rate of consumption? What are kilowatts? Joules per second. So kilowatts are measure a rate. Okay, it is the amount of energy that is consumed, which is what we have here. So remember, units can be your friend. So this equation here gives me a rate. It gives me kilowatts. Okay, so what does the problem actually want me to find? So I want the consumption over a day. I don't want the rate of consumption anymore. I want the total amount. I'm going to need to integrate it. Okay. And we could do this whole thing where we take our little delta t's and our c of tk and all that nonsense, but the bottom line is we're going to integrate it. So what am I going to integrate? So I'm going to integrate the rate of consumption with respect to time from 0 to 24 because I want to do it over a whole day. So this is my rate, and I'm effectively multiplying it by an amount of time. And so my rate, I don't know exactly what it looks like, but it's going to look something like that, right? Because it's something minus a sine function, so it's really just shifted up. Okay. And if I find, so this is C of t. Okay, I can find the rate, I can find the amount that's consumed over this delta t. And then I add up all my delta t's, and that's what my integral is. All right, you with me? Okay, so integral 0 to 24, 3.9 minus 2.4 sine pi t over 12 dt. And now this is why we spent all of chapter 7 and a good chunk of chapter 6 learning how to take integrals. So remember that this is really two integrals, right? So what's the integral of 3.9 dt? Shock, horror, please. No. Shock, horror. Disappointment will come later. When I can't